All right, so a quick review of composition of functions here. And then we're going to get into limits of compositions. So first, remember the idea of composition of functions is that you're going to take one function and take its output and stick it into a second function. So we end up with something that looks like f of g of x. Now, you've probably seen me draw this before, the idea of the functions as machines, and so input, output becomes a new input, and then we get a final output. I just want to draw this again with slight change. As we have numbers going in and coming out, and then going in and coming out again, the very first independent variable input is generally called x, right? And when we are dealing with a function, usually the output is called y. So what we get over here is called y. And that leaves this gap in the middle. If you're dealing with function names, you can call it g of x, and then you can call this f of g of x. But like if you're dealing with variable names, well, what are we going to call this? Traditionally, people will call this u. You'll hear about u substitution. You'll hear about, with function composition, you'll hear about this sort of middleman variable, which is u. So I'm going to use that basically for g of x. U and g of x will be the same. So we want to suppose that we're in a situation where we have a function composition, which means that y is some function f, and it depends on u, the variable u. So y depends on u, and u is a function of x. U depends on x. All right, so that's the situation, and then so y is f of g of x. All right, so y depends on u. U in turn depends on x. So therefore y depends on x via this composition of functions. Okay, so now limits. So suppose that we have this composition, and the limit as x approaches c of our inner function, g of x, is going to equal L, which basically means we're assuming that that limit exists. Okay? That was 1. 2, suppose also that the limit as x approaches L, so this limit value here, as, sorry, I used x, but I should have used a different variable. I should have used u. The limit as u approaches L of f of u is going to be f of L. So in particular, that means not only that the limit exists, but if it's equal to the function value, that means f is continuous at L. Okay? Then if we take the limit as x approaches c, again, x, our independent variable, is approaching c, of the composition of functions, f of g of x, what we get out of that is f of the limit as x approaches c of the g of x. In other words, we can sort of pass this limit inside the outer function. Okay, if our f is continuous, we can take the limit and stick it inside f like this, and so now we're applying the limit just to the inner function. And then, of course, if we said that that limit exists and equals L, then that's going to be f of L overall. So that's basically it. That's how you can deal with composition. This part here is kind of the thing to remember, that as long as, and it has these stipulations at the beginning as well, as long as f is a continuous function, you can pass the limit inside that function and apply it to the inner one. See what you get from that, right? That if that limit needs to exist for you to be able to do this. So see what limit you get from that, and then evaluate the limit. So that's kind of the rule to remember working with. I think I can show you an example. I'm going to put an example of this in the next video.